Oh. Hey, there it is. Nice. Okay. Hi, everyone. Let me start a timer. Keep an eye on it. Okay. This was, I will admit, built for 30 minutes. So I'm going to try to talk double fast, record this, play it back at half speed. Also, if you do play it in reverse, there are some hidden messages. Thank you for that joke. Very, very appreciated. Okay, so I'm going to be talking about, I did start talking about hybrid development environments. Hold on, there's some on the screen. No. Okay, we're okay. So this is something I've been working on at my gig for the past year and a half. I really lucked out. Now, this is gonna be a decent amount of bragging. I was hired on to this company, was told by the VP of engineering that the infrastructure was trash and that he wanted me to rebuild all of the underlying infrastructure, Terraform all over the place. I will start religious wars. I'm not using Pulumi. So Jake, if you're listening, there it is. Okay, so let's dive into it. So we're going to talk about first what the problem is that we're trying to solve with hybrid development environments. Then I'll explain what a hybrid development environment is, how we have gone about implementing them at my company, and some practical considerations if you do decide to do this yourself. So about me really quick, I started programming in Second Life 15 years ago. Has anyone else in here written a line of London scripting language? Hell yeah. Cool, I've been doing this for 7 years, all DevOps. I'm currently working at a company called The Network, no vowels, pretty cool. It's based in LA. It's a live stream retailer. It's basically QVC for millennials, and apologies to my CEO who does not want us to describe it like that. This is my email address. I came up with it while I was in college and thought it was really cool. So feel free to email me. I don't really have Twitter or anything because I just get mad and yell at people.
How much junk do you get?
Huh?
How much junk emails do you get?
Thankfully, none. So please don't sign me up for stuff, y'all. Come on. Okay. So the problem we're trying to solve here is microservice development. It's getting bigger and bigger and bigger. You have dozens of services running. How do you run all of these things? There's a lot of complexity. There's computational overhead. Your ability to make your computer run slow is so much better than Intel's ability to make a faster CPU. And your software complexity is just, as a rule, going to grow faster than your computational capacity. There's also cognitive overhead for a developer. How do you run these dozens of things? I mean, even if everything is defined in a consistent way, figuring out and just modeling in your brain all of these different things running and how they interact with each other, especially if you have to consider it on your local machine versus differences of how it runs in production. Developers ideally should just be focusing on business logic and not having to worry about the cognitive overhead of all this stuff. There's also organizational overhead, right? We want consistent development environments between different developers. It is a big problem when something works on someone's computer and doesn't work on someone else's, not only because what's broken, but also because it takes time. People reach out to me and are like, why isn't this working? Fix it. And I'm like, no, I have other important things to do. So minimizing how often that happens is important. Sharing work, let's keep going. Okay. So there are common solutions, bare metal, get it? The issue here is that your development environments are going to be inconsistent across your organization. Like I said earlier, Intel, they suck. You're way better at making stuff go fast or slow than they are making things go fast. You're also going to be, there's complexity with deploying it. Do you want to run a subset of things or deploy everything? If you are running a subset of things, are you starting each of those things individually, or do you have a script that runs them all at the same time? Next good step, Docker Compose. We used this at my previous gig, and it was actually pretty good, but also production doesn't run Docker Compose, and if your production does run Docker Compose, God help you. Having containerized common deploy definitions are fantastic, but there's also complexity integrating it into local development. When you're running Docker Compose, or when you're running Docker on a Windows machine or a MacBook, it's running in a Linux virtual machine on that computer. And so you've got all these layers of abstraction. So routing the traffic in and out of there is difficult. It's also, yeah, it's not production-like. So what do we want? We want something that is simple to deploy, simple to maintain, consistent across developers, and ideally production-like. And wow, big surprise, hybrid development environments. That's what I think is a pretty good solution. The premise here is that you run basically everything in Kubernetes in the cloud in a namespace that is specific to the developer. We also do namespaces per branch in our pull requests, but that's beside the point. So you run basically everything in the cloud, and then whatever you're actively working on, you run on your local machine. You can have a debugger running, you can have whatever running. You don't need to redeploy all of these different things because it's just running on your local machine. And developers can just develop the way that they're used to. But how do we interact with all that stuff? We use like networking magic or whatever. You basically just trick the cluster and trick the laptop into thinking that the laptop is in the cluster. We have a service called Backstage, which is like a web page that is an internal service. And we'll deploy Backstage and our API into a developer's namespace, but then intercept all the traffic that's going to Backstage in the cloud and redirect it to the local machine, and then take all the traffic from Backstage and send that up into the cloud. It was really cool when I was showing a developer this, and he was running Backstage on his local machine and set up a debug breakpoint. We intercepted the traffic and I hit it through the public DNS, and then it triggered the breakpoint on his machine. It was like, oh, so sweet. So yeah, this is awesome because it's production-like, which means developers are developing in a production-like environment, which is fantastic. And it means way less work for me, which rules, because I don't have to build different tools for deploying to different environments. It also means that developers are exposed to operations stuff and day-to-day work because they are literally working with Kubernetes, which is what production is running in, on a day-to-day basis to do their jobs. So like, I have not had to respond, I hope this is real wood, to like a production incident in like 4 or 5 months because literally every single developer understands how Kubernetes works because they use it every single day. Here's another diagram. Yeah, namespaces, stuff running on laptop, networking magic. Does anyone else work with anything like this?
Have you used Cloud9 before?
Oh yeah, oh, I really struggled. But yeah, it's a really cool idea. Yeah, that's definitely worth looking into. Okay, so let's talk about implementation challenges here. There's still a lot of complexity. How do you build everything? How do you deploy everything? Like, I talked about those being issues, but if not, putting it in the cloud doesn't magically make it easier. And how do you connect everything? I'm a really big fan of simplifying tooling. That's going to be a common theme as I try to finish this up in about 7 more minutes. Only introduce complexity when necessary. Like, we have such a tendency to come to these conferences and, ooh, you see so many cool things that people are doing and you want to do all those cool things, but you really, really, really have to push back against that because minimizing cognitive overhead, keep things simple, is just absolutely critical. Simplify concepts, minimize the number of workflows, minimize cognitive overhead. It's so critical. I'm a really big fan of it. So let's talk about simplifying the tooling. Building and deploying. Like I said, complex systems are really cool. And if you have a need to implement them, absolutely go for it. But for now, like, let's just focus on the basics. We have a single entry point for building and deploying anything and everything. We have about 30 different deployments, but there's only one command that you ever use to build things. There's only one command that you ever use to deploy things. We use a tool called Scaffold that Google made that has, frankly, like really bad documentation, but it's like decent. Yeah. But it works really well. We define all of our builds in here, all of our deploys in here, and you basically just run Scaffold build or Scaffold deploy with some configuration options to set it to like dev, staging, production, etc. Wrap them to make commands, bing, bang, boom. You have the same tool for deploying. The thing that you use for deploying to your development environment is the same as for staging and production, which rules. It's really, really nice. And like I said, you just pass in different configurations for different environments. So let's talk about that single build and deploy path really quick. Your workflows shouldn't be pets. Like, you shouldn't have unique workflows as much as possible, just because then a developer from like one side of the company coming to another team, they're going to be confused. It's much better if they all use the exact same workflows. Minimize cognitive overhead. I need to count how many times I have it in here. Yeah, like I said, reduces the tooling development workload, which less work for me is fantastic. Mostly just being able to focus on useful things is really cool. So our single build path, we have 30 things that when you run the build, it tries to build all 30 things, but those are all built into Docker images, and we tag them with the Git hash that they were created from. And a good Docker build is deterministic, meaning that if you run it from the same source code, it'll always result in the same thing. So before doing a Docker build, we check the Git hash of the commit that it's being built at. And if anyone else in the company or a CI server has built it, we don't need to build it. Yeah, and then you get cache hits on like everything you didn't change. So this, counterintuitively, you can, with like Docker and Scaffold, have one command that builds everything, but will only actually build the things that changed. Same with a single deploy path. It's like the trolley problem, except instead of having two options, you only have one, and instead of deciding between killing one person and 5, you're just building and deploying code. I thought this was a good fun joke. So yeah, we deploy into environment-specific. You have environment-specific configurations for your deploys. We use Helm to bake the YAML. Configuration is passed in. And yeah, Kubernetes just only updates what changes. So even though you're deploying 30 things, it's only updating the actual stuff that changes. So you have one command to build, one command to deploy. Implementation details. Yeah, we have a repo called Platform K8s. It's the source of truth for all the building and deploying. Everything is defined in there. It's a common framework. And all engineers can contribute to this. And this rules that of our 29 engineers, 21 of them have contributed to like infrastructure code. It rules. No one has to talk to me to add a new service. I just have like a file that they read, and then they just add it, and they run it in their development environment, and bing, bang, boom. All they need to do, because things are deployed the same way, is just promote that to staging and then production.
What is it called again? What's the name of it?
Oh, well, this is stuff that we've baked. Platform K8s is just the name of our repo. But we use Scaffold as the main tool to stitch everything together, sort of. This is also kind of a neat idea. I realized, I was wondering, like, how do we cache everything as optimally as possible? And, you know, like I said, when you're running Docker on your local machine, it's actually running on a Linux VM. And when you run Docker commands into your CLI, it's actually hitting an API in that virtual machine. So like, I realized that I could just run Docker in our Kubernetes cluster, and then using that like networking magic, basically whenever a developer runs a command to build a Docker image, it runs that on an actual server in our cluster. So I like built a 1.5 gigabyte image yesterday while I was at a brewery, and like was connected on my phone, but didn't have to push 1.5 gigs because it all built in the cluster. Yeah, it's also nice because it doesn't slow down the machines. Okay, let's go. Okay, how do we interact with the cluster? There's a really cool tool called telepresence that you basically just run telepresence connect, and then it routes traffic from your local machine to the cluster. Like you have access to Kubernetes internal DNS addresses, which is like fantastic, especially because if one developer is having issues with their environment, another developer can literally just telepresence connect and then connect to their environment, like literally just poke around in their database. And because everything is already running in the cluster, yeah, you don't need access to the developer's local machine. And we're all remote, so like that rules. K9s, if there's one thing you can take away from this talk, if you use Kubernetes, use K9s. It's incredible. It's a GUI that runs in your command line that makes interacting with Kubernetes super easy. You can like shell into containers, you can kick off jobs manually, you can look at logs and stuff. So this is how all of our developers interact with the cluster. Okay. Managed services. What do we do with that? We can't be spinning up an RDS instance for every single developer. Production does run RDS though. So this is the part where we start to deviate from production. You just deploy MySQL pod, set up a pod disruption budget, make sure it doesn't get rescheduled. But this is really nice because it's disposable and developers can experiment with it a lot. We were having an effort to try to move over to Postgres, and developers were just able to experiment with it in their personal clusters. Cool, let's keep going. So the workflow. Developers run this command repo sync, which in that platform case repo, we have a YAML that defines every single repo and the path relative to that directory that is used to build things. They run this one command. If they're missing any repos, clones them down, pulls down the latest default branch, and they can also pass in a branch as an argument, and it will check out that branch if it exists, otherwise fall back to main. So it's super easy. If you want to check out the production code on your local machine, you just run repo sync production, and it will update your local machine, all the production code on there. Then make build dev, and that builds for your dev environment. Make deploy dev. I think y'all can figure that one out. And you run telepresence connect and do dev work. And like, if it breaks, just turn it off and on again, which I did an IT internship and I'm a very big fan of it. Okay. So some pitfalls, telepresence. If you have different versions, they step on each other. Guess how we found that out, right? Developers losing connections, and it's kind of really frustrating. So we've had to like compile our own internal telepresence binary, distribute that to developers, pin your version, make sure everyone uses the same version. Ideally, everything needs to conform. You want to minimize the number of pets that you have. You need to have everything deploying into the same system for it to really, really work super well. This is also unorthodox. Like most developers haven't worked like this. And so there are some cognitive boundaries that people need to push past. You will answer the same question 10,000 times. And no matter the different ways, be it in a demo day, be it an @channel in Slack, be it documentation, they'll never learn. But whatever, it's worth it, it's cool. Yeah, and it pays off. Like, the devs are really big fans. There was a learning curve, but it's not too steep. We have just one tool chain that everything is built and deployed and developed around. It's really production-like. And it also means that then high achievers can contribute to your operations and your ephemeral environments. One of my coworkers, Yohei, he just like literally just got fed up that we didn't have data seeding. And he asked his manager to like spend a week building data seeding, and at the end of the week did a demo where he showed like these ephemeral environments being super useful because he had built data seeding. It was incredible. Another coworker, Swaru, he checked out this really cool service called Kata. I don't know what it stands for, but it basically allows you to scale things automatically based upon Kafka depth queue. I didn't tell him anything about this. We just had a developer who like thought it would be cool to see if he could implement auto scaling and was able to do it in ephemeral environments, and I literally touched nothing around it. So like, it's fantastic because developers can do infrastructure and ops work. Yeah, we also had someone, we don't have UI tests. We're getting there though. And one of our coworkers built UI tests for mobile environments and developed it against these ephemeral environments running the API. Yeah, and now we're getting web UI tested that is being developed in these ephemeral environments. So it's the multiplicative effort or the effects once you actually get all this stuff implemented rules. That's it.
Okay, I know you don't use EKS, AWS EKS, ECS, and ECR.
We use EKS and ECR. Yeah, I hate Docker Hub. No offense to anyone in here that really digs it, but like, yeah, they rate limit you, and just put everything in ECR. Like, pin your versions, put everything in ECR. Yeah. Cool.
Good work, man.
That's it.
Good work.
Oh, thank you. Thank you.